Okay, lesson 6-4. Today we're going to talk about factoring sum and difference of cubes, solving sum and difference of cubes, and factoring using the grouping method. Okay. So let's recall from what we've learned in the past. Let's say you have something like 4x squared minus 25. Okay. This was known as a difference of squares. Right? And there were three requirements that I gave you in order for a problem to be a difference of squares. First one, you have two terms. Second, it has to be a minus sign. That's why it's called difference. And the third, right, both of these terms need to be perfect squares. Okay, they have to be perfect squares. Okay, so meaning there is something that we can square to get this. In this case, it would be 2x. Right, and what would we square to get the 25? It would be 5. Right, so since these are perfect squares, we have two terms and it's a minus sign, this problem is a difference of squares. And as you recall, when we factor it, right, our binomials are just conjugates of each other. 2x minus 5 and 2x plus 5. Oops, should be a minus. Right, so this was a difference of squares. So today you're going to learn about, first of all, say you have something like this. This is considered a difference of cubes. Now, why is this a difference of cubes? The three requirements are pretty much the same. We have two terms. It's a minus sign. And the third requirement, these are perfect cubes. So instead of perfect squares, they are perfect cubes. Right? Meaning there is something cubed that will give you this, in this case, x. And there is something cubed that will give you this, in this case, 2. Alright? So when you factor this, right? So when you factor a difference of cubes, it's not quite as easy as a difference of squares, but once you learn the pattern, it's pretty easy. The factors will always be a binomial followed by a trinomial, right, and they're multiplying with each other. Right? Now, to get the signs for your binomial and trinomial, you have to remember this kind of little trick. It's called SOAP, meaning the S stands for the same. So whatever this sign is, it's the same thing in the binomial. This sign right here is O for opposite, right? So it would be positive in this case. And the last sign, AP, for always positive. This sign is always positive right here. All right, so same, opposite, always positive. So this gets you your signs. And then once you have your signs, you could take these values right here that you've already found, plug them into the binomial, x and the 2. Okay? To fill in your trinomial, to get this term right here, you take this, whatever this is, right, and you square it. So in this case, you get x squared. To get the middle, you multiply these two. So that's x times 2. That'll give you 2x. To get the last term here, you take this, whatever value this is, and you square it. So you get 4. Okay? And this is your answer right here. So these are the factors, factors of x to the third minus 8. Right? Meaning if you FOIL this right here, I guarantee you will get x to the third minus 8. Alright? So you've just factored a difference of cubes. Okay? Now, when we're talking about cubes, we also have sums. For example, let's say something like 27x to the third plus, let's say 8. So this here would be considered a sum of cubes. Right? So why is it a sum of cubes? Alright, the requirements are pretty much the same. We have two terms. We have a plus sign obviously instead of minus. And then we have perfect cubes. Okay, perfect cubes. So because what to the third power gives you this? 3x. What to the third power gives you this? 2. So if we factor this now, right? Remember we're always going to have a binomial followed by a trinomial. And then we use SOAP to get our signs, right? Fill in the signs first. So S for same, opposite, always positive, right? Same, opposite, always positive. Remember we did the same thing for the last example. We did same, opposite, always positive. And then the 3x and the 2, right? Let's fill them in. So the 3x here and the 2, plug them into the binomial. To get this, alright, to get this value here, take whatever this is, alright, this value, you square it. So 3x, if you square it, you get 9x squared. To get the middle, you multiply these two. 3x times 2 gives you 6x. To get the last term, you square whatever this is. So 2 squared is 4. And then you've just factored a sum of cubes. Okay? So the pattern is actually really, really simple. Alright? Let's take a look at another one. So let's say we need to factor 128 x to the third minus 1. Sorry, minus 2. Okay? Now, you have to recognize, sum and difference of cubes or maybe difference of squares when you see them. Right? So anytime you have two terms, right? Remember when you're factoring, what's always the first step when you're factoring? Right? The first step is always to look for a GCF. Right? It doesn't matter what type of problem you have. When you're factoring, you look for a GCF. So you can take out a 2 from here. So if you take out a 2, you end up with 64x to the third minus 1. Okay? You notice here, this would not be a difference of cubes because these are not perfect cubes. But then you should recognize, oh, I could take out a GCF. And then look at what we have now, right? These values are perfect cubes. This is 4x to the third power gives us this. And obviously 1 to the third power gives us 1. So we have a difference of cubes in here, okay? So we're going to factor this now. Alright, same, opposite, always positive. Right? To get these values, you just plug in these right here, right? Into our binomial. To get this, we square this. That's 16x squared. To get the middle, we multiply these two. 4x. To get the last term, we square the 1. So 1. So you just factored a difference of cubes, right? Now just don't forget, if you take out a GCF at the beginning, it's got to be part of your answer. So this right here, your full answer. And if you want to know if it's correct, if you multiply all this, it will give you this. Okay, it will give you this. If it doesn't, then either you multiplied wrong or you factored incorrectly. Okay? Is everything this right here? This expresses the pattern that I showed you right now. Alright, just with variables. Okay, so for sum and difference of cubes, alright, is this explaining how you get the values and everything like that? Alright, using variables. Okay? So that was factoring. So we just factored. Alright, this is how to factor, right, a sum or difference of cubes. Let's talk about what do we do if we need. Okay, let's say we need to solve 27x to the third plus 1 is equal to 0. Okay, so in order to solve this, the first step we need to factor. So when we factor, you look for a GCF. Is there a GCF? There's no GCF. So then we're going to factor this. So then we recognize, oh, this is a sum of cubes. What cube gives you this? 3x. What cube gives you this? 1. Right? So let's factor this. So we end up with, use SOAP, same, opposite, always positive. So we end up with 3x and 1. To get this term right here, we square this, we get 9x squared. To get the middle, multiply these, 3x. To get the last one, square it, you get 1. Right, so we have 3x plus 1 right here times 9x squared minus 3x plus 1. So when will this equal 0? Well, if this is 0, right, if whatever this is 0, or 0 times anything gets you 0. So if this is 0, it doesn't matter what this is, the whole thing will be 0. Or if this is 0, right, if this equals 0, it doesn't matter what this is, 0 times whatever this is makes the whole thing 0. So when will 3x plus 1 equal 0? Well, when x is equal to negative 1/3. When will 9x squared minus 3x plus 1 equal 0? Well, aren't you just solving a quadratic here? We've been doing this all chapter. So to solve this, all right, you would try the x first. All right, 8 times c, 9. We're trying to get b, which is negative 3. Are any values going to work? Nope, so the x doesn't work. So if the x doesn't work, you have two choices. You could either complete the square or use the quadratic formula. I believe many of you prefer the quadratic formula, so we'll use that. So x is equal to negative, what's b? Negative 3. Plus or minus the square root of b squared, alright, so we have negative 3 squared minus 4 times a times c, all over 2 times a, which is 9. So if we do the work, we're going to end up with positive 3 plus or minus. In here, we work this out, we're going to end up with positive 9 minus 36. So this is going to give us the square root of negative 27. So if you simplify this, we're going to end up with 3i square root 3 over 18. Okay? Now we know we're not done because we can take out a GCF from here to reduce with this. So if we take out the GCF, which is 3, we end up with 1 plus or minus I square root 3 over 18, and that lets us simplify the 3 and the 18. We divide those. So your final answer would be x is equal to 1 plus or minus I square root 3 over 6. Alright, and remember, we have two solutions here. We have 1 plus I rad 3 over 6, and the other one is 1 minus I rad 3 over 6. Right, so these are our three values of x, right? These are the three values of x that if you plug them in here, it's going to equal 0 because it'll either make this 0 or this 0. Okay, so when you're asked to solve, you're trying to find out what x equals. Okay, let's try one more. Let's say we need to solve 250 x to the third minus 2 is equal to 0. So obviously these are not, difference of cubes, right? Because this is not a difference of cubes right now because these are not perfect cubes. But if you recognize, we can take out a 2. So then we end up with 125 x to the third minus 1 is equal to 0. And then now you should recognize, oh, these are perfect cubes because 5x to the third power gives me this, and 1 to the third power gives me this. So if you factor this now, you'll end up with, instead of our binomials, binomial and trinomial. Alright, so we've got same, opposite, always positive. We have 5x and 1, 25x squared, 5x and 1. So when is this going to equal 0? When will 5x minus 1 equal 0? When x is equal to 1/5. When will this equal 0? When will 25x squared plus 5x plus 1 equal 0? Well, you can try the x. Alright, a times c, 25. We're trying to get 5. It doesn't look like anything's going to work. Okay, let me give you guys a hint. Anytime you factor a difference or sum of cubes, right? So anytime you factor a difference or sum of cubes, this quadratic right here, right? The x will never work. You won't be able to solve it using the x. It's just not going to work, right? So don't even waste your time. Just take these values, a, b, and c, plug them into the quadratic form. So negative, what's b in this case? 5. Plus or minus square root of 5 squared minus 4 times 25 times 1. All over 2 times a, which is 25. Right? So we end up with x is equal to negative 5 plus or minus the square root of, so 5 squared is 25. Minus, what do we get right here? 4 times 25 is 100, so minus 100 times 1. So we end up with the square root of negative 75. So you simplify this right here, right? So you know you can have an I, and then you have basically 25 times 3, so you're going to end up with 5i square root 3 over 5 times, 25 times 2 is 50. And then we can take out a 5 to reduce, so we end up with negative 1 plus or minus I rad 3 over 50. These simplify, so your answer is going to be x is equal to negative 1 plus or minus I square root 3 over 10. Okay? So that's how you solve a sum or difference of cubes. Nothing complicated, right? Now, one thing you have to pay attention to, when we took out the GCF here, you notice our GCF was 2. So do you need to have a 0 as an answer? We don't, right? So be careful there. Because if you take out, let's say, if we had taken out like a 2x, right? If it has an x, then you need to have 0 as one of your solutions, remember? So be careful about that, okay? But it didn't have an x, so we don't need a 0, okay? Alright, now let's talk about factoring a polynomial with 4 terms. Now, if there's a polynomial with 4 terms and we need to factor it, you can't use the x here because you have 4 terms, right? Like here's a, b, and c, like what's this right here? So you have to factor using the method we call grouping, right? Grouping means that we're going to group these two together, right? The first 2 terms together and the last 2 terms together. 90% of the time, if you just group the first 2 and the last 2 together, it's going to work out for you, okay? If it doesn't, you could try to group some different terms together to see if it'll work, and if it still doesn't, then it may not be factorable, okay? Let me show you what to do here. So once we have this right here, you take out the GCF. So with this group here, we take out the GCF. In this case, it's going to be x squared, right? And then that'll give us x plus 4. Over here, we take out the GCF, it's positive 2, and then we would get x plus 4, all right? So if you're doing it correctly, these terms right here, right, they have to be the same, okay? These binomials here, they need to be exactly the same, right? That tells you that you're doing the problem correctly. If they're not the same, that means that you need to either group, set up some different groups, or you cannot factor this, okay? It all depends on, what type of problems you're given. So, but since they are the same, we can continue. So from this step here, what you do is you take your GCFs, right, these right here, whatever you factored out, and then you group them together into one binomial. X squared plus 2. And then these, the x plus 4, you notice how you have 2 of them here? You only need to write it one time, right? You only need 1. And I'll explain why you only need 1. Right? So this would be our answer right here. So why do we only need x plus 4 once here if there's 2 of them over here? Well, if we take a look at and think about what's happening here, you're taking x squared and you're distributing it into here, right? Well, over here, if you FOIL like you normally would, you would take x squared and you would distribute it into x and 4, the same thing as over here, right? Over here, you would distribute 2, take 2 and distribute it into x plus 4. Well, if you're FOILing, you would take 2 next and distribute it into the x and the 4. So that's why you only need to write this one time. If you write another x plus 4, this wouldn't be, like if you add another one right here, right at the end right here, right, this would not be equal to this right here. It wouldn't be the same thing. So that's why you only need x plus 4 once. Okay, and this is our answer right here. All right, and if you want to know if it's right, FOIL all this, it will give you this right here. Okay, now let me show you. We could get the same answer, right? Let me write the answer. It's x squared plus 2 times x plus 4. We could get the same answer if we group the problem differently. Okay, for example, instead of grouping the first two terms and the last two terms, what if I group the first term with the third term? And what if I group the second term with the fourth term, the 8? Right. So what would we take out from here? We would take out an x. We'd end up with x squared plus 2. What would we take out from here? A positive 4. We'd end up with x squared plus 2. These are the same, and they have to be. Alright, so we're on the right track. So what's our answer going to be? Well, we take the GCFs, x plus 4, group them together, and then the binomials that repeat, we write it one time. And you notice we get the same answer, it's just, in a different order, right? But it means the same thing, right? So this shows you that you can group them in different ways, and if you do it correctly, you'll get the correct answer still. But one thing you want to keep in mind, when you're setting up your groupings, you want to have it so that they have a GCF. All right, set it up so that they're going to have a GCF. Okay, occasionally there may be a group that doesn't have a GCF, but it's probably not needed. Okay, so let's take a look at number 2. So number 2 here, once again, like I said, if you just group the first two and the last two, it'll usually work out for you already. Okay, if it doesn't, then maybe you need to try a different grouping set, but usually it works out. So what can we take out from here? GCF is 3x squared. So this will leave us with x plus 2. Over here, now you notice here we have a negative 4x minus 8. We need x to be positive, right? So in order for this to be positive, we have to take out a negative 4, because then x will be positive, which is what we need because these need to be the same. So once we do this, these are the same. Good, we're on the right track. So what's our answer going to be? 3x squared minus 4, x plus 2. Alright, and that's your answer. Real simple. Okay, so factor by grouping is really simple, nothing complicated about it. Okay?